show that the general solution of this differential equation can be written as y equals a cosine t plus b sine t, cos or cosine hyperbolic, sin or sine hyperbolic. So to solve this homogeneous differential equation, we find the corresponding characteristic equation. So the corresponding characteristic equation, this is r to the fourth, it's a fourth derivative, means r to the fourth minus, there is no derivative, it's 1, the coefficient is 1, r to the fourth minus 1 equals 0. Now we solve this equation for r. Now we can factor this like r squared plus 1, r squared minus 1 equals 0. We can factor this further. Anyway, this gives us r equals plus minus 1, and r squared plus 1 equals 0 means r squared equals negative 1. Square root of negative 1 is plus minus 1i, this I. And we know that based on these roots, plus we have the solution e raised to rt. Okay, so from this we get e raised to t plus 1t and e raised to negative t, negative 1t. These are two solutions, and based on this, these are complex conjugates, so there is no real part here. So e raised to 0, that part is gone, so just cosine of 1t and sine of 1t. So these are the four solutions of this differential equation, and we write down the general solution is a times some arbitrary constant times cosine plus another b sine plus c and etc. But if we look at closely here, we want slightly different general solution. Cosine, we have that. Sine, we have that. But we want here cos and sin. But we have exponential functions. And as we know, these cos and sins are just the linear combinations of these two solutions, these two functions. Okay, and from the principle of superposition, we know that any linear combination of solutions is also a solution. So these are two solutions. If we make a linear combination like this, half multiply by half and multiply by half again, a to the negative t, this is a linear combination of these two solutions, so this is also a solution. And this one is exactly cos, okay, is a solution. And if we multiply first by half, multiply second by negative 1/2 and combine, this is also a solution by the principle of superposition, and this is in fact just sin sine hyperbolic t. So we got one cosine, sine, these are regular cosine, sine, and cos, sin, four solutions. Then we can write down a general solution, y equals any arbitrary constant. So we want a, b, c, d, or we could have written c1, c2, c3, c4, same thing. So not c1, we want a cosine plus b sine plus c cos plus d sin. Okay, and this is what we want, final